All right, so our last example here. So similar function here. This time we're just gonna find f primed at positive 1. Okay. So and you can use a table or whatever you'd like, and you can use either formula. Once again, we're gonna stick to the most common one here, which is our increment formula. So f of a plus h minus f of a all over h as h approaches 0, right? And so the things we'll need to do is we'll need to find f of a plus h, right? So we do a plus h squared plus 3 times a plus h plus 2, right? So I'm just plugging in the values for a plus h in there for x. All right, so now we operate. So this we've seen a lot, so it's going to be, I keep doing this, but let's replace this a with a 1, right? So a is 1 in this case. All right, so I'll put a 1 in here, 1 in here, and a 1 in here, right? And so if I square 1 plus h, that's going to be 1 plus h multiplied by itself. And so that ends up being 1 plus 2h plus h squared. If I distribute here, I'm going to get 3 plus 3h. Then I'll just tack on that 2. And so now I'm going to combine like terms. So there's only 1h squared. And then there's a 2h and a 3h. So that makes 5h. And then the constants, there's a 1 plus 3 is 4 plus 2 is 6. All right. And so that's what I'll put as I kind of build this formula out. F primed at 1 is going to be the limit as h approaches 0 of, and so now I have this figured out, right, which is h squared plus 5h plus 6 minus, now let's figure out f of a, which in this case is f of 3. So I'm just going to plug in 3 in these input locations, right? So 3 squared plus 3 times 3 plus 2. So 3 squared is 9. So that's 9. 3 times 3 is 9. So 9 plus 9 is 18 plus 2 is 20. All right, that was silly because we're not doing at 3. Got used to doing 3s. That should just be 1, right? I'm sorry. And so this should be a 1, 1, 1. And so 1 squared is 1. 3 times 1 is 3. So 1 plus 3 is 4 plus 2 is 6. And the reason I kind of figured that out is because I knew that this should cancel out like we've seen with the pattern. And so I was thinking it's not, something's wrong with that. All right. And so I'm going to put an h on the bottom there. And so now we can see that these do cancel out, in fact, which has been the pattern so far, right? And so what will happen is we'll get h squared plus 5h. You can actually just factor in that step instead of rewriting this one more time. But just to make sure we're all on the same page, I just want to show it step by step here. And so now I can factor out an h. It's a common factor. So it's going to be h plus 5 left over in the parentheses. Now we can see these h's cancel out. And so what we're going to have left is the limit as h approaches 0 of just h plus 5. And we can directly evaluate that now and plug in 0. And so 0 plus 5 is 5. And so we just found that f primed at 1 equals 5. All right. Cool. And so in the next lesson, we'll talk about velocity and average or an instantaneous rate of change a little more specifically, which is basically the same thing. And so just kind of put in a physical value to it, or kind of put in context to these numbers where they're not just x's and y's on a page, but they're actually can relate to real life situations.